In the previous section, we described while loop considerations on an FPGA VI. By the end of this module, you will be able to create delays between events using the wait express VI. So in this block diagram, you're able to see how you can use the wait express VI to create a delay between events. So when are some times you might need to do something like this? Well, one example is if you need to create a delay between a trigger and a subsequent output, or if you ever need to create a series of delays in your program. So for example, maybe you need to output something on your digital output, and then you need to wait a certain amount of time because of the protocol, and then after you wait that certain amount of time, maybe you change the digital outputs to something else, and then you wait a certain amount of time, and so on and so forth. So there could be many different situations where you need to create a delay between a series of events that are happening. So if we take a look at this particular block diagram, it looks like we are outputting on a digital output line, and in this case we're setting a digital line 0 and digital line 1 both to true, so we're making them into a high voltage. Then we're doing a certain defined amount of delay, and then we're going to flip digital line 0 to false, and then we're going to wait a little bit again, and then we're going to flip digital line 1 back to false as well. So this is just one example of creating delays between events. So in this slide, we see how we can configure the wait express VI. So if you were to double click that wait express VI, we would get a pretty familiar looking dialog. So the first thing you want to do here is you want to figure out, okay, what are the units you want to use for the wait? Do you want to use ticks, microseconds, or milliseconds? And then after you determine that, then you got to figure out what is the size of the internal counter. So again, the internal counter, that's going to determine what's the maximum wait that you can define for that particular function. So if you want something very big numbers, then you want to use 32-bit. If your numbers are going to be smaller, for example, between 0 and 255, then you can use 8-bit. Okay, so let's kind of compare and contrast how the loop timer express VI works and how the wait express VI works. So if we take a look at this code here, it looks pretty similar, at least the code structure does, except on the left we're using a loop timer express VI, and on the right we're using a wait express VI. So let's take a look at the loop timer one first, okay? So let's say that code in the second frame, let's just pretend it takes 25 ticks. So if that was the case, then when we run this particular VI, the very first iteration, the loop timer express VI is going to just figure out that initial timestamp and then go to the second frame immediately. That second frame, let's say it takes 25 milliseconds, and then it finishes and we go to the next iteration of that while loop. Now, as that while loop keeps executing, that while loop will execute every 50 ticks. And that's because the loop timer express VI is making sure that that while loop is executing every 50 ticks. So the loop express VI is basically trying to ensure the loop execution rate. Now let's contrast that with the right side. So on the right side, we have a wait express VI. So the wait express VI will explicitly wait 50 ticks every single time it's called. So let's walk through this, and let's again pretend that the second frame in the sequence structure is going to take 25 ticks. So if we take a look at that, the very first iteration, it's going to execute that wait express VI, which is going to take 50 ticks. And then the second frame, let's say that takes 25 ticks. So that single loop iteration is going to take about 75 ticks. So if we keep running this while loop over and over again, because that wait express VI is explicitly waiting 50 ticks each time, and that second frame is taking 25 ticks to run each time, that loop rate will actually be executing once every 75 ticks. So one way to kind of think about this is in Windows, the loop timer express VI is more like the wait until next millisecond function, and the wait express VI is more like the wait function. So that's kind of one way to think about it. Now you can create delays between events using the wait express VI. Next, we will measure time between events using the tick count express VI.